Okay, so today we're going to take what we learned about the Bohr model, the last two class periods, and practice drawing how typically Bohr models are drawn on paper. So Bohr described electrons in what? Electrons exist in energy levels, right? And what did he say about those energy levels? He said they're circular. They're the circular paths that electrons travel. So when we draw Bohr models, we draw circles, circles to represent each energy level. So we're going to have our nucleus. What's going to go in the nucleus? Protons and neutrons. And then the electrons are going to be organized into energy levels. So the first ring represents what energy level? First. And how many electrons hold at most? Second ring is what energy level? Second. And how many electrons can it hold? 8. The third ring represents the third energy level. How many electrons can it hold? 18. I am not going to ask you to draw anything bigger than even just a partially filled third energy level. Now, could you be asked on a test for the maximum number of electrons in the 20th energy level? Yes. Do we have a way to figure that out? What? That equation? The 2 times n squared. So you take the energy level, square it, and multiply by 2. So you don't even need to memorize the 2, 8, 18 because you can figure those out. Okay? So now, when we talked about Bohr's experiments, we drew the energy levels as lines, and what happened to those lines as we went up in energy levels? They got closer together. You can draw that on your circular Bohr models. It's just not as commonly done. It would, of course, be the best way to represent it. It just, for space's sake, is not often how they're drawn. But you'll get to practice with drawing those electron transitions in the problems we're going to work today. Okay? So let's do an example together before we go down to the modeled examples. I don't know why I want to do this. Let's pick an element that's not too big. Nitrogen. So let's do the Bohr model for nitrogen. So, how many protons does nitrogen always have? 7. If it's neutral, how many electrons do it have? 7. What's the average atomic mass of nitrogen? Anybody on your periodic table? .07, is that right? 0.1. So I didn't give you the mass number in this problem, right? But if we look at the average atomic mass, do you think you could reasonably predict the most abundant isotope of nitrogen? Nitrogen-14. So most isotopes of nitrogen are going to have how many neutrons then? 7. So when you're not given the mass number, the best way to try to estimate how many neutrons is take the average atomic mass and round it to the nearest whole number and use that. You don't know for sure that that's the case, but it actually works out most of the time. So let's draw our Bohr model. So where are we going to put the protons and neutrons? In the nucleus. Okay. How many electrons do we have to show? 7. So can I put them all on the first energy level? No, why not? It can only hold 2. So once I put 2 electrons there, that energy level is full. So I'm going to need a second energy level. Now here's where kids will make mistakes. They get working too quickly. They'll draw the second energy level and then they'll think 8, which it is true, the second energy level can hold 8 electrons, but for nitrogen, are there 8 electrons in the second energy level? How many are there? 5. So we've already accounted for 2 of them, right? Level. Another way you can draw these, if you prefer, is neutrons in the nucleus. And then you can just draw particles and write 2 electrons here and 5 electrons. I forgot the 2. 2 electrons here. If you are a really visual person and that helps you to understand things, I would encourage you to go with the first one, because what we're actually going to use the Bohr models to help us visualize is when we get into bonding, where we have electrons being transferred and shared, we can use the Bohr model to help us visualize that. So either one's fine. If you tend to be a more visual person, you may want to practice the one on the left, because you'll probably end up liking that. Okay? Let's do examples. Start off with a big one. Draw the Bohr model for argon 40. What is that 40? Mass number. Which is, why are we going to do that? So we can figure out how many neutrons? So argon always, always, always has how many protons? 18. So I can go ahead and do 18 in the nucleus. How am I going to do protons? There you go. 40 minus 18 gives us what? 22? And I personally, because I am prone towards making careless mistakes, I like to think through how I'm going to draw the model before I start drawing it. So, is the first energy level going to be full? Yes, so I'm going to need the first energy level. And then I'll need the second energy level. Is it going to be full? Yes. And so then I'm also going to need the third energy level. Is the third energy level going to be full? No, but it is going to have some electrons on it, in it, around it. So how many electrons am I going to put on the first energy level? 2. And then is the second energy level going to be full? Yes, so how many am I going to put there? 8. So right now, how many electrons have I accounted for? 10. How many more do I need to account for? 8. And will all 8 of those fit on the third energy level? Yes. Now, for some of you, you may be like, okay, fine, I can do the Bohr models like this when I need them, but that's too messy for me. I like the other way. Do what makes the most sense to you, okay? Okay, the next one, we're going to draw the Bohr model for neutral sodium and the sodium ion, and we're told to assume that they both have electrons. You guys try neutral sodium. We're going to do them all together, but you guys try those. That one. they tell us to assume that in this case, sodium has 12 neutrons. So I'm going to fill that in for both. So when they say neutral sodium, what does that tell us? Same number of electrons and protons. So it's going to have 11 electrons. The sodium ion, if we find it on our periodic table, what's going to happen to it when it forms an ion? It's going to lose one electron. So it's going to be a... So how many electrons will it have? 10. How did I know it was going to lose one electron? It is an alkali metal in group 1. So what is it going to do to look like its nearest noble gas neighbor? Lose one electron to look like who? Neon? Good. So, protons and neutrons in the nucleus. How many electrons on the first energy level? 2 is full. Second energy level for neutral sodium, 8. And we need energy level, right? How many electrons? 1. Is that 8, 5? Yep. Good. Then what happens for the sodium ion? How is it going to look different? It's going to have 10 electrons. So is it going to have any electrons in that third energy level? No. Now when we describe energy levels, it's not that the energy level is like a shelf and it disappears if there aren't electrons there. It just means there won't be electrons. We wouldn't expect electrons to occupy that area. And we're going to fine-tune that more when we talk about quantum mechanical models. Good. Okay, you guys try 3. Find oxygen on your periodic table. Who's the nearest noble gas neighbor to oxygen? Neon. So what is oxygen going to have to do to have the same electron arrangement as neon? It's going to gain electrons. So how many electrons will it have? 10. And the symbol is O2 minus. So now, still 2 electrons on the first energy level, right? How many in the second energy level? 8. So what can we say about that second energy level now? So said ions, atom ions to be more stable and to have a full, we said outer energy level. This is an example of that. And if we look back at the sodium ion, when it lost 1 electron, is its outermost energy level full then, if you look at your notes? Yes, that second energy level is full with how many electrons? 8. Okay, now let's practice drawing the energy level diagrams, so the lines that show electron transitions. So it says, draw and label an energy level diagram for hydrogen, the hydrogen atom. In your diagram, show the series of 4 lines in the infrared and visible emission spectrum are produced, clearly labeling each. So, this is a lot to dissect. So when they say draw energy level diagrams, that means I need to draw those lines, right? And how do I draw those lines? What happens to them? They're going to get closer together as energy increases. Right? So, I'm going to draw the first energy level. And what is that closest to? Nucleus. The first energy level is equal to 1. And the second energy level then what? Third. Fourth. I'm going to need to make sure. How many energy levels am I going to need? I'm going to need 8. It's going to get close together. 5, 6, 7. How did I know I needed 8? Anybody? I'm asked to show 4 lines for the infrared and visible. So if it's emission, are electrons going to be going from lower to higher or higher to lower? Higher to lower. If it involves transitions to or from the first energy level, what type of light does it involve? Ultraviolet? What about the second energy level? Visible? And the third? Infrared. So you guys said it's emission, right? So it's going to be going down. So if I need 4 lines showing visible emission, do I have some choices? Can I go first to second? No. What would first to second be? Absorption of ultraviolet. So for emission of visible, I'm going to be going down to the second. So can I do third energy level to second? Yes. What else? Fourth to second? That's 2 invisible. What else? Fifth to second. And sixth to second. Those would be visible, 4 different wavelengths or frequencies of visible emission. What about infrared emission? Still, am I going to start at and on the third energy level. I'm going to land on. So can I do fourth to third? That would be 1. What else? Fifth to third. Sixth to third. And what do those represent? Infrared emission. Very good. So first thing I needed to do was draw my energy levels, right? And that will get you points. If you can just draw the energy levels, number them, and show them getting close together, that will give you points. I needed to recognize that visible would be second energy level, and infrared would be third, so that's 2 more points. And then I needed to show that it was emission. So since it's emission, it's going to be falling to those energy levels. What would be switched if this question asks for absorption in infrared and visible? What's the only thing I would need to do? Switch the way the arrows are pointing. They point up. So visible absorption starts at the second energy level and goes up to higher. What about infrared absorption? Where would it start? It would start at the third energy level and go up. And what about ultraviolet absorption? Start at first and go up. I know this is a long ways off, but this kind of question is on almost every IB chemistry test, and it's like a 4-mark question, which means 4 points, and it might be the only question that's worth that many points on an IB test. So if you're planning to move forward with IB chemistry, and you can feel comfortable with this year, it's not that it's hard, it's just you have to be careful with emission or absorption, remembering first energy level ultraviolet, second energy level visible, and third energy level infrared. How do we feel about that? Good?